Well, thanks very much, everyone. You can see I've just been warned by one of my SSC members, Pashkar, there, that when people start looking towards the door, it's because the drinks are just behind there. So bear with me. I'll try not to be too long, and I'm sure they're going to keep the white wine on ice for us. So thanks very much for being invited to the public forum, and I just wanted to give you some insight into the observations we've been doing in the Southern Ocean that are revealing some of the new time and space scales that haven't really been observed before until recently. And these are centered around what we call the Southern Ocean seasonal cycle experiments. So I come from CSIR, as Andrew mentioned, and it's a group called the Southern Ocean Carbon and Climate Observatory in Cape Town in South Africa. And we have a range of activities that span from the ship to autonomous platforms and modeling included. So historically, we've been quite limited in space to observing the Southern Ocean. This is kind of a picture that we had pre-2010, which was really limited to ship observations. And this is where, for example, our program went, and many other nations look similar to this. And you might say, wow, okay, it covers quite a fair part of the Southern Ocean. But indeed, the temporal scales of ships being there are very, very short. And so this was really a problem that has been coming for Southern Ocean observing. And if you look at some of the historical times of observations and profiles of physics, you can see in 1998, there's really just a big blank space there with one or two cruisers coming out of the Drake Passage. And then 10 or 15 years later, you see suddenly all these dots start to be populated that are a combination of ships and as well as the deployment of Argo floats. And if you kind of summarize it, you can see this massive change of no observations with just the ships going down in the summer periods. These are the ship transects that are occurring in time here over latitude. And then boom, we have this sort of data explosion occurring as all these Argo floats have been deployed from around 2004 onwards. And here we go, seeing sort of the dawn of SOOS that was started to occur in 2011, 2012. And you might think, well, wow, this is a hell of a lot of observations, and it must, teach us a lot about what's happening in the Southern Ocean. And indeed, it did revolutionize really oceanography as we've seen it for the last couple of decades. And yet, when you try and look at a picture like this, and Sang-Hoon had his favorite picture, and this is one of mine, and that's really because these ocean color images, monthly means from a satellite, show that there's a hell of a lot going on. And that ranges from regional variability, cyclic, episodic, patches of blooms, chlorophyll blooms occurring in the Southern Ocean. And this whole region, the Southern Ocean, is so remote, for us to collect observations. It's a harsh environment. It's really expensive to get there. And so the Argo Float program was, first of all, not taking measurements of biogeochemistry, and also actually their temporal resolution of this 10-day sampling was not really enough to capture all of this variability that occurs in these short time scale physics processes to biological responses. And so that's why we really started to look at using robotics in the ocean to fill these temporal and spatial gaps. And so for those of you who don't know, these gliders go up and down the ocean to about 1,000 meters depth, and they send us the data back every few hours and collect new commands from us of where else to go, and maybe what sensors to switch on or switch off to save some battery, et cetera, et cetera. And they have autonomy for up to about 6 months or so. So the activities that have come out of the South African Marine Engineering and Robotics Center have kind of launched some of the glider activities that we've seen in South Africa that is filling this sort of Venn diagram of the spatial and time scales. And you can see that ships can occupy very well in the spatial scales, and moorings are very good in the temporal, but of course are fixed in one place. And Argo floats start to fill some of this area, but not really enough to look at the fine scale dynamics that might be impacting seasonal scales. And so the gliders seem to start to cover into that area that help us to understand how the climate might change into the future. So what we did was, a good example was the first seasonal cycle experiment. So in 2012, we went out with the ship and we deployed a set of 5 of these gliders, a little glider fleet, what we call it, south of Gough Island here in the South Atlantic Ocean. And then we deployed another 3 more on the Good Hope monitoring line, which runs between Cape Town and Antarctica. And so we piloted these gliders across the Southern Ocean in the Sub-Antarctic towards the Good Hope line so that they could interact and intersect with the ships to be picked up later when required in the summer periods. So we have this spatial coverage that ranges from the early spring and sort of the late winter conditions into spring, summer, and towards the end of the bloom. And if you look at that sort of time-space scale observations, you can see these 2 gliders are moving, and here's the time changing from October to late summer, spring to late summer, and you can see these gliders picking up this patch of green, which is referred to as the Sub-Antarctic bloom. And it does quite a good job at, we guided them as to where the bloom was occurring to make sure we tried to capture the majority of it. And over that same period, if we didn't have the gliders, you kind of look at what else we would have had and available to us through the other observational platforms. And so that blue line, again in time here, this is just one variable. We call it mixed layer depth. And so that blue line is derived from these monthly climatologies that we have that are gathered, called an EN3 product, where all the observations are gathered to make a monthly mean. And you can see it's kind of resolves some sort of scale variability, some cycle, sort of seasonal cycle of deeper mixed layers in the spring towards shallower in the summer. And then you have a better resolved product, which is a 7-day product, the CFSR reanalysis product. And you can see, that picks up some more variability and some more wiggles and more stuff is going on over there. And then if you superimpose the actual observations that we took with the glider, you can see really the completely different timescales that we were observing there. So we have adjustments here in the mixed layer. For those of you who know upper ocean oceanography, the mixed layer here was adjusting by 250 meters or so in the span of a day, which is really considerable. So to give you some insights of the spatial, I use this slide to sort of demonstrate the spatial observations that the gliders were observing. You can see up the top panel there is temperature, we've got stratification, and we've got chlorophyll A, so essentially how much phytoplankton is growing in the upper ocean. And you can see there's lots of variability, things are happening, there's these little features and stuff, and these gliders are what we say resolving the submesoscale. And they're starting to observe things that are less than 10 kilometers in size. So little eddies and filaments and jets that are predominant in the Southern Ocean and really haven't been observed properly before. So, and then just recently, we've just published a new paper which was deriving new variables. So the biologists and the biogeochemists here, we started to derive things like net community production, etc., from some of the backscatter data. So that's a spatial kind of, I use it as a sort of spatial, mode to have a look at. And if you look at the temporal mode, and here I use just, the other half of one glider's data set, and you can see that there's lots of variability in some of the variables, in the mixed layer depth, and again in the chlorophyll here in the time series. And we couldn't really explain what was going on here until we started to look at the winds of the Southern Ocean. And when you see the winds, they seem to correlate very well with some of those variables, and they were really the only mechanism to explain how the ocean was changing in this temporal scale. And here's just an example of some of the observations of satellite of the winds in the Southern Ocean. And you can see they happen so rapidly that can you imagine a ship going down for a 1 or 2 week period to get to the Antarctic continent would just capture a little slither of one of these storms going past it. And in fact, a couple of days later, the environment might be really, really different. So having consistent long-term and high-resolution observations are going to start revealing the impacts of these kind of maps onto the environment. These very high-frequency winds are just one of the examples. And they're very, very variable. I mean, they've got hurricane-force winds, even in the middle of the summer periods, as those of you who've been to the Southern Ocean will know. There's many problems, and this is another favorite of mine, and I was chatting to Jolene earlier about some of the biofouling that they have on the floats, etc. And I mean, these gooseneck barnacles are growing on our gliders. This glider was out for about 150 days and diving to 1,000 meter depth continuously. And these gooseneck barnacles were still having a great time, growing readily and destroying vast amount of data, as you can imagine. We have the power sensor, they're looking at light in the water column, which is supposed to have this black body underneath it. And now suddenly there's all these lovely light, shiny shells. And this is when the gliders are out of the water. When they're in the water, these things open up to about 5 times the size when they start feeding. So you can imagine the impacts they have on the glider behavior. The next step, which I just wanted to introduce you to, was having wave gliders. And wave gliders are surface gliders that stay on the surface and use wave power to get around. And they also have autonomy for long periods of time because they're powered by solar panels that keep their sensors going. And obviously wave energy, especially in the Southern Ocean, is endless and bountiful. So these wave gliders can go out in the Southern Ocean, are very robust, and can continuously measure processes that are happening on the surface. So they're very valuable at looking at the surface fluxes. And this, in this particular case, is a CO2 measuring wave glider, looking at how the CO2 is exchanging between the atmosphere and the ocean. So we put these gliders down in the Southern Ocean, and we're looking at, where would we actually put these gliders? And so this kind of map here shows the correlation between the annual cycle, the continuous annual cycle of chlorophyll A, and the actual time series. So when you correlate those two and you have very low correlations, it means that actually there's so much variability going on that's very dissimilar to the actual seasonal cycle. And when the time series follows a very predictable seasonal cycle, we have very high correlations. So you can see in the subtropics, there's a really strong seasonal cycle with those high correlations. And when you start getting into regions of the Southern Ocean, this drops off dramatically. And in fact, about more than 30% of the Southern Ocean is characterized as having very low seasonal cycle reproducibility. And so we put one of our gliders in these areas, in the Sub-Antarctic zone. And what we did was we paired them. So we took actually the diving gliders that were going to 1,000 meters, and we put it together with a little surface wave glider. And we tried to keep them together as best as possible. And in fact, they did a great job at staying on track. You can see this is the actual track of one of the wave gliders going in this octagon sampling strategy that we kept it to within about 6 kilometers of the diving glider that was diving underneath it. And this really allowed us to get observations extending from the deep ocean. Well, the deep ocean, 1,000 meters, is not really the deep ocean, but deeper than the mixed layers, all the way into the mixed layer, the surface processes, and the atmosphere, and looking at the fluxes. So that's been really a very nice area that's kind of changed the way we've been doing research in our group, and having these kind of observations have really advanced some of those questions that we had. And here is just a little snapshot of some of the data. So this is the CO2 flux, so how much carbon dioxide is going between the atmosphere and the ocean. And so this is a 4-month time series of those wave gliders that were in 2 years ago. And you can see again that it's characterized by lots of high frequency variability. It's not just this lovely seasonal cycle as we might have thought there would be 10 years ago or so. And recent results have started to show that the carbon community has been wanting to reduce the uncertainty of CO2 fluxes to less than 10%. And so here we have the time series sampled at different sampling intervals. So this is the perfect mean over here. So this is the glider is sampling CO2 every hour. So the hourly mean over the seasonal cycle is this value over here. And in fact, when you start to increase the sampling frequency, suddenly the uncertainty of the measurement becomes greater and greater, and we have this expanding cone. And so, and this really starts to get outside of the 10% uncertainty very quickly at day 3. So this suggests that if we want to know what is the true CO2 flux that has an uncertainty of less than 10%, we should actually be sampling this region at higher frequencies than 3 days, which is quite a shock, because we thought we could go there maybe once every 3 months or so, and there's been other studies that have suggested this. Not long, Andrea, promise. So this is, it's not just about the gliders, though, I want to emphasize. It's really about using the gliders in combination with other platforms that SOOS really tries to bring across that will really enhance the observations and the research that we're doing. So the gliders can't be used alone. They have to be married with things like ships that can sample many other aspects that gliders can't. Satellites gives us those overall pictures and understanding what's going on the surface. And then, of course, there's the numerical modeling and the high-performance computing to provide integrated approaches to doing Earth system science. And we hope to further that this coming July, and that will really allow us to give the first winter observations from these gliders extending from July until late summer next year. And I hope, we'll start to get some understanding of how, even in such a small experiment compared to SOOS, we'll start to learn some of the mistakes and how to actually implement that within a SOOS 20-year vision as it rolls out. And so when we look at a diagram like this again, and these were the Argo floats, we'll probably go back, in 10 years' time, we'll look back and we'll say, perhaps this is actually the era of the gliders, and we'll start seeing these observations being a predominant one in the Southern Ocean. Thanks very much.